Hello and good morning, good afternoon, good evening, depending on where you are. Thank you very much for making time to attend this webinar, which is the first webinar in a series of 3 webinars on this exciting limit equilibrium slope stability analysis tool from rock science called Slide2. Those of you who are already using the latest version of Slide2 know about its capabilities, and those who are not would get a glimpse of some of those capabilities in the presentation today. And today's presentation, as I said, which is the first in a series of webinars, is titled Past, Present, and the Future. So I'll talk to you about and share with you about some of the past history, the past achievements, talk about what the capabilities are in the present version, and what is in store for you in near future. My name is Manoj Varman, and without using up much of your time, I'll straight away go to the presentation. And I hope you can see the presentation on your screens, and the title, as it says, Past, Present, and the Future, about Slide2 M+. M+ indicates that the latest Slide2. And as I said, my name is Manoj Varman, and I'm representing rock science in India and the rest of South Asia. And so in this presentation, we would be talking about some of these things: the design philosophy of rock science at large, and Slide2 in particular, and some of the past unique achievements of this wonderful software tool. We'll talk about Slide2 M+, which is the current version, and where we are going from now, what is in future, what's in store for you in near future. So as far as the design philosophy is concerned, the main thing, the major thing, the principal thing, which is at the top of the mind of the developers of Slide2, and has always been so, is making it easy for the users to use the software, the user interface, and the user friendliness. In fact, all of the rock science tools are known for their user friendliness, and the same applies to Slide2. And so right from the time the development of Slide2 started, it was one of the top priorities of the developers to give a good user experience, ease of use. And those of you who are already using Slide2 and other rock science tools, they know what I'm trying to say. Continuing in the same vein is like the effort made by the developers, and they're still on, to minimize the modeling time, because it was realized very early in the development stage that all of rock science's users are busy people especially who's using Slide2 for slope stability analysis and design issues, the busy people. And so let's make their life a little easier by cutting down on the modeling time as much as possible. So all the developments have really focused on making sure that the modeling time required is minimal, because for some of the complex models, the modeling time can take days, if not days, then hours. And so there has been a conscious effort, or efforts in the past, still continuing. We'll see some glimpses of those towards reducing the modeling time and saving time for the users to focus on the results and interpretation and application of these tools to their problems at hand. And while making sure that the user experience is great, while making sure that the modeling time is reduced as much as possible, it is of paramount importance to stay accurate and verified. And the developers of Slide2 were very conscious about it. And in fact, Slide2 was one of the first in the world to produce a verification document based on more than 100 verifications of published results. And in fact, before the release of Slide2, over 1,000 test models were run to make sure that the results are accurate and results are verified. And in addition, the last point, those who already use Slide2 would vouch for it, that rock science and the developers of Slide2 have made every conscious effort to utilize whatever technologies available from all branches of engineering and science in making sure that you get all of this experience, such as getting an accurate factor of safety. And a brief history of Slide2. And what you see on the screen is a picture of 4 of these developers who got together in early 1990s in University of Toronto to start working on the development of Slide2. And those were the DOS days, you know, DOS, the operating systems, DOS, not Windows. And the people you see on the screen have grown up now in every sense of the word. And Igor, and you have Kevin, Warren, and the extreme right you have Brent, who is currently Dr. Brent Corcoran, who is currently the Chief Technology Officer at Rock Science, and he's also the Chief Architect of Slide2. So those are the ones. And if you scroll through and you see that and come to summer of 2017, 11-person development team, and in fact, typically 10 to 15 people are now involved in developments related to Slide2, and many of them with advanced degrees such as PhDs in engineering. So it's like Rock Science puts some of the best people in development of Slide2, and Slide2 has grown. Many features have been added. They're being added right now as we speak. And the journey from 1990s to 2020 has been a very interesting journey. And it's really interesting to see what all developments took place during this journey. Of course, we have to do that in a brief time for you to see that how Slide2 has grown and to see how Slide2 has reached where it has reached today. And so some of the slides which are coming up will focus on that. And so this screen that you see, this screenshot is from 1995. And so the DOS days, the last decade of the last millennium, 1990 to 2000, and with the stars in their eyes, the developers working on something very exciting, Slide2. But what you see is nothing like what we have today in Slide2. Those were the DOS days, and what you see on the screen is very interesting to see that Slide2 was one of the first to realize the importance of having a factor safety map, although it looks a little crude, a little rudimentary at that stage, which is what you would expect 25 years back. And but then the factor safety map to see how factor safety varies through the slope model, and very interesting features. And of course, you can also see only circular slip surfaces were used. Of course, now we have many more options, non-circular slip surfaces, several search methods. And so it has really, really grown over a period of 25 years, Slide2. And so going forward, then in 2000, the first few years of this new millennium, where the Windows version was introduced, version 3 of Slide. And one of the major features of version 3 at Windows was the inclusion of freeform geometry entry, that facility to do freeform. Up to that point, the method of entering the boundaries, etc., was like based on you could only do from left to right or from top to bottom. So those were the things which were at that time. And imagine if you have a geometry like the one which is given here on the right. How would you do that if you have just the facility of doing from left to right and top to bottom? So it was realized very early by the developers of Slide2 that this is not the way to do things. This is not the way to create the boundaries. And for something like the one you have here on the right, would take hours and hours to do this geometry by using the age-old concept of left to right and top to bottom. So freeform entry was introduced in version 3, on the first Windows version. And so the slide now allows you to draw the boundaries wherever you want to. So it's a unique thing. Wherever you want, you can start and draw the boundary, the material boundary, the external boundary, and stuff like that. And what it also does, it has facilitated the import of CAD packages into Slide. So you can read or import the AutoCAD file, a DXF for instance, into Slide2, and you don't have to recreate the geometry. Sometimes you may require a bit of geometry cleanup, and once you do that, you're good to go. So even the complex geometries can be managed very easily. And even if you're not importing for example, the one which is shown here, it will be done in about 10-15 minutes at the maximum with current facility of freeform geometry entry available. And so that was a major change in this version 3. And then version 4, and this was the years 2002, 2003. And what was done in version 4, that one of the major features was integrated groundwater analysis was introduced, which was kind of a finite element based unsaturated groundwater analysis. And what was done, we used the same geometry as the slope geometry, the geometry used for slope stability. Same geometry was used for this groundwater analysis, and measuring was done using Delaunay triangulation. So very simple, one-click measuring. So it was a unique feature in Slide. Now, coming to the support models, up to that point, the bolt models were very simplistic, and what you could do was define a capacity of the bolt model, maybe the direction, maybe not, and the location where to put them, and that's about it. But it was realized that people would like to work with real supports, so those were introduced in this, and the different modes of failures were introduced. For instance, in a typical bolt model, when you look at the force diagram, bolt force diagram, or in the case of soil nails, nail force diagram, you would see the failure at pull out, the stripping, the tensile, and all of those were introduced in version 4, and the real support were introduced. And now what you have extensive library of supports in Slide 2, for example, there is geosynthetics, geotextile, etc. You have bolts, you have anchors, you have tiebacks, and all of that stuff you have it now. So you work with real supports now. So this was version 4, and then came version 5, and which was there for several years. And one of the, or in fact, shall I say, it was all about the probabilistic analysis of overall slope. Up to that point, the statistics, the probabilistic analysis was on global minimum only. Now, for those of you who want to know a bit more about probabilistic, it's an exciting development in geotechnical engineering. Now, I assume that many of us are from geotechnical background, and one of the major problems that we deal with in of course, getting the reliable input parameters, input data, because as they say, garbage in, garbage out. If you get good input data, you can do a good analysis and give reliable results. So getting reliable input data in geotechnical engineering has remained a challenge. And not just that, in addition to the problem of getting good and reliable input data, there's an inherent variability in geotechnical material properties. So as you know, that it's very difficult to say that this material has just one fixed value of a parameter for cohesion or friction, for instance. It's very difficult because the variation of the geotechnical material, these are natural material, not man-made material. So you cannot guarantee a particular property value. And so you have to work with the range. Often designers find it difficult that to carry out what is called a deterministic analysis, which value of the parameter to take. For example, you have 4, 5, 6 input parameters, and for a deterministic analysis, you would need one value. Which value to take from the range which is given to you, and maximum, minimum, average, mean. So that's a problem. Probabilistic analysis allows you to take a range of parameters. So you have a mean value, and then you can have a distribution of values, and you can choose what kind of distribution you want, from minimum to maximum, what kind of range of input parameters you want. So obviously, when you take into account a range of parameters for several input parameters, then you are looking at thousands of combinations of these input parameters in terms of the results. Thousands of analyses are possible, and which are done under probabilistic analysis. So up to this point, till version 5 was introduced, the Slide 2 had probabilistic analysis feature for the global minimum. So once you find the global minimum, and the probabilistic analysis, the statistical variation of values was done on the global minimum. But then it was realized fairly early by the developer of Slide 2 that if you talk about variation across the slope and not just the global minimum, this would completely change the mode of failure. And so it is more realistic to look at the overall slope rather than look at the overall slope as far as the probabilistic analysis is concerned, rather than working with the global minimum only. And that was a major shift and a major enhancement in the capability of Slide 2. In addition, the local optimization was added. The slip surface vertices on the local level were moved by the software, which is called smart hunting, in order to find a lower factor of safety. As you know, although the software may produce a global minimum surface, but it is entirely possible to find a factor of safety which is lower than what is given by the global minimum by changing several things. And once you go through slide 2, and those of course who've been using, they know about this. So once you go through these things, you will know that it is possible to find a global minimum. So constantly the developers are trying to refine slide 2 so that the user actually finds the lowest factor of safety, which is so crucial for the stability analysis of any slope. And so you need software to do the optimization. So this optimization was introduced, but on a local level, which was a local level. So while this was a step in the right direction, this is not the final aim where the developers wanted to reach. And so obviously, but this was the right step, and the step led to further developments in this, as you will see. And so moving forward, then came the version 6, and the second decade of the new millennium, and the version 6, and there were rapid developments taking place all over. The technology was improving fast, and also at the same time, interestingly, infrastructure projects were becoming more exciting. Countries around the world were getting into more difficult areas, and more complex problems were being looked at, and to aid all of that, the development in the technology also helped. And as the modeling was becoming faster, the computation was becoming faster, more and more features were being added, and slide 2 responded, kept on responding, it still is actually. And so transient groundwater analysis was added in version 6, and so far the facility was there for steady state analysis of groundwater, and the transient analysis was added in this version. And in addition, the global optimization were introduced by what is put under the global meta-heuristic optimization of non-circular surfaces. In slide you get an option of choosing between a circular and non-circular. And if you remember from your school days, from your college days, we were all told, the first thing we were told by the circular slip circle failures. And now we all know that the failures could be non-circular as well. And in fact, that's a pretty developed subject now. And when you choose non-circular, you have lots of options under this drop-down menu where my cursor is at the moment of search method. And so in version 6, the global meta-heuristic optimization added by including simulated annealing search method. And if you want to know the details, the best is to go to the help menu under slide and read about these things in details. And of course, another exciting development was anisotropic strength models were introduced. Now, you know that these geotechnical material can be anisotropic, and especially the customers who are dealing with the rock engineering situations, and also people from the mining side dealing with open pit mines. And after having excavated through the overburden, you go into the rock conditions, rock mass. You're dealing with rock mass, and which can be very anisotropic. One of the things about rock mass which actually makes it so different from other materials is the anisotropy, which is so predominant in most rock masses that you deal with. And so anisotropic strength models, responding to the need of those customers, the anisotropic strength models were added to slide 2 in version 6. And in version 6 also, more things were done. And one of the other exciting thing is integration with RS2. RS2 is a general purpose finite element program from rock science, very powerful. And I'm sure many of you must be using it or must have heard about it. It was called phase 2 then, when version 6 of slide 2 was in vogue. And it was at that time, shear strength reduction model, which you do in finite element program, was kind of becoming popular, although people was still debating it. Now, of course, it's pretty common. People very commonly use SSR, shear strength reduction model, for slope stability analysis using a finite element approach. And so it was thought that why not try to integrate Slide2 with RS2, so that when you're working with RS2 finite element, you can import the Slide2 model and see how does the factor of safety obtained from Slide2 limit equilibrium package like Slide2 compare with the factor of safety obtained from RS2 using SSR. And there are advantages of finite element modeling, and so the whole idea was to see that if they really compare well, it will give you confidence in your model. And so now it's a very pretty established technique, and those of you who have RS2 as well as Slide2, if you've not used it, please try and use this. And now, of course, in the latest versions, all the Slide2 material models, shall I say, are now available in RS2 for a seamless and for a very easy integration with RS2. So that was another feature added to version 6. And then in 2015 came version 7. And one of the major features of version 7 was this exciting multiple scenario modeling which was added. And as you can see on your screens right now, you can in a single file, in a single document file, you could have different scenarios open. You create a geometry to start with, and you have some material boundaries and material properties, all of that you've done, and you want to tweak something, you want to change something, and you want to have all of them in one document. It's now possible with multiple scenario modeling, and that's what you can see, that you can change the angle slightly, and you see how, and you run the model. You can include seismic force in one and not in the other one. And so all of those can be seen on one screen, one document file. They can be computed by one click. So this facility was added in multiple scenario modeling in version 7. Okay, moving forward. In version 7 also, RS pile support analysis was added. Now this is really exciting because I'm sorry about this. RS pile is a finite element based package for analysis of piles. And so up to this point, what people used to do, people who wanted to use piles with the slopes, they would need the shear force value, for instance, or axial strength, and that would be calculated or determined from an independent analysis using RS pile or L pile or stuff like that. And then that will be brought in to a package like Slide2, and Slide2 will give the location of the failure surface, the location of stratigraphy, this profile, the soil profile that you see, and the shear force and axial strength information which you will bring from here would be incorporated, and the analysis would be run. And so this was a long process. And now what Rock Science has done, the developers of Slide2 have done, they've integrated the process. So what it does that it works with RS pile, and what it does is that from Slide you get the stratigraphy, this profile, you get the location of the failure surface, and from the finite element analysis of RS pile, you get the the stiffness of the soils, the mechanical properties of pile, and a design slope movement. And then this computes the shear strength and axial strength at the slip surface location. So slip surface, which is given by the Slide2, the RS pile actually calculates the shear strength and axial strength in the pile at the slip surface location and feeds it back to the slide analysis as a support force. So you don't have to do it; it gets done automatically. So it's a very seamless integration and fully automated. Works very well with this. So that was one very exciting feature in version 7. Some more features were added to version 7, and one of them was working with Sarma non-vertical slices. And and this was incorporated in Slide2, the Sarma non-vertical slices, and also optimization between the wedges. So inter-wedge boundaries were included, and you can now compare the results with the vertical slice method, the results obtained from the non-vertical slices with the vertical slice method. So that was another feature with version 7. And version 7 is not done yet, actually. This was one of the major And many features were added, as you can see. Several slides are devoted to the features added in version 7. And so still continuing with version 7, all of these will also added. Soil profile or geological models. What it does is that, even without this, when you create, you start doing the modeling, you create the external boundary, you create the middle boundary and stuff like that. So you can actually build the soil profile by creating several layers of different types of materials, which actually are likely to exist at the site where you're going to cut a slope. And so, but what this feature does, the soil profiling feature, which is part of slide 2 now, is that it allows you to create a template, a base template of the soil profile which exists, soil profile of the geological model which exists. And this is especially useful when you have multi-layer kind of situation, and you want to see various scenarios superimposed on that. To give you an example, if you're familiar with what happens in open cast mine, suppose there's a situation where you have these deep open cast mines, which is where the slopes are being cut, slopes and benches, through a multi-layered strata and several layers of different materials. And so you can create the template, you can incorporate all those material layers and assign the properties to them under soil profile options. And then using the template, you can only superimpose the slope, cut it to different angles. And one of the things about the stability of slopes, especially in mining, because you want to keep it as steep as possible, but at the same time you want to keep it safe. So you really want to know how much you can cut back. What is the slope angle, what's the bench angles. So you can try out various angles, for example, without changing the soil profile, which is there in the template. So, but if you have a simple model, a simple soil profile, not a multi-layered one or two layers, etc., then perhaps you can do it normal way. But if you're really in a complex kind of situation, multi-layered strata, where you want to check various scenarios, not the soil profile, but various scenarios, then this is a very, very handy tool. And try it, you will know what I mean. And in addition to this soil profile, advanced correlation were added. And advanced correlation is something like between two random variables. The correlation, if you have several materials in a model, several zones in the model, and in those zones the same materials are there, and so the correlation between two random variables is a pretty useful feature to have. It actually improves your analysis results much. And so those were added in version 7. As far as seismic analysis is concerned, new mark method was added, and also you could now do critical seismic coefficient, could include the critical seismic coefficient. For the search methods in non-circular surfaces, cuckoo search was added, and over a period of time, the cuckoo search has become the search method of choice. And in fact, when you start and when you go to the option of choosing a search method, cuckoo search shows as a default method, because it has been found that this is the best, gives you the best results. Of course, there are other search methods which work very well, but this is the default search method. Cuckoo search was added in version 7. So version 7, as I said, did a lot of things, and then came the version 8, and the year is 2018. So we are coming closer to the present time. And so one of the exciting features, and I've been using this word exciting too many times, it seems, but that's how they are very exciting. And actually, when you try them, you will know how exciting they can be, and then you can think about the possibilities of how you can use these features, how you can implement them to improve your not just the analysis, but the understanding of how the structure will behave when actually constructed. So one of the exciting features, once again, I'm using the word spatial statistics, which was added to version 8 in 2018. And we've been talking about probabilistic analysis, which actually allows you to have a distribution of the values of certain parameters. And so what this does, and sometime back I mentioned about the inherent variability in the property values of geotechnical materials. And this inherent variability is also very pronounced in terms of space. So, horizontally, for example, if you drill a borehole here, at the same depth, you take a sample, and a borehole, say, 10, 15, 20 meters, 50 meters away in the same area, and at the same depth, you take the sample. The chances are very, very rare that you'll get the exact same property. So there is a variation both in terms of horizontal space as well as vertical space. So this spatial variation is now possible to be incorporated in the probabilistic analysis. So you can actually distribute the values in terms of space, and the experience says, and as you would also imagine, the variation in vertical space is much more, maybe 10 times more than the horizontal, and it is more so in terms of rock mass kind of situation, especially the sedimentary layered rock masses, where the way they were formed, you have different layers, and while horizontally the difference would be just as you would imagine in any geotechnical material, but vertically downwards you could be dealing with completely different geological histories, and so therefore very different property values. And so, but it's now possible to incorporate, and it's very easy. That the great thing about this is it's very easy. Try this, and I'm sure you'll agree with me that this is exciting. And so, in addition, in version 8, other features such as the surface altering optimization was added, and which is all part of the search methods, and particle swarm optimization was also added. And it's the optimization method when you try to optimize to find a lower factor of safety. And so various forms of optimizations are available which help you in finding a lower factor of safety. So in that story, these were added. But another great feature which was added was, remember in the beginning I told you that the developers are always conscious of giving the best experience to the users and to make it faster for them. And so at that time I was talking about the faster modeling, but now I'm talking about the fast computation. So in this version, in 2018 version 8, several parallel computations were added, which actually made the speed of computation 10 times faster. So the complex geometries and the complex model which would run for hours, they can be done 10 times faster. So if you have a version which is older than version 8, try and upgrade it, and it'll save you a lot of time. And saving time is not just saving time, but also in the time saved, you could run more models. Often you find that if I could tweak this geometry a little bit, if I could just change this a little bit here and run the model, and but then you are working under the pressure. Since I come from the industry, I know that that the settings in a typical research institute or an academic institute can be very different from the industry. The design offices, when the project is running, is under construction or going to be under construction, and so those are the situations where you are always under pressure of time. But a good design will take its own time. So whatever the developers can do, they're trying their best to do. So now with this parallel computation, you can run several analyses in the same time. And so try this. If you have an older version, you'll see the difference immediately. And in addition to these features, in 2018 version 8, the soil nails were added, and EFW, equivalent fluid weight pile facility, was added, which is often required by the structure engineers to model the piles. And so you can go to the help menu to read about these things. And I strongly encourage, I would always tell everybody, especially the youngsters, the new users of Slide2 or any of the rock science tools, that the help menu is great. So when you are, even if you are trying to learn the software and you're going through the tutorials, which you must do, and you come across something, you might want to skip it because you're so excited to see the results, and you say, I'll come back to this later. But don't do that, except for a few things which are really for the advanced study. Go to the help menu there. You come across EFW, go to the help menu there and then, and read about it. So it will enhance your knowledge of the software, all right, but of the subject. And in course of time, you'll really become an expert. That's a message I always give to the youngsters. And so another thing which was added in version 8, which because I work a lot with rock engineering, with the weak layers. And so while it is possible, even before that, it was possible, still now possible, to model a layer of weak material in the middle of a relatively stronger material. By using the material boundary option, you can give the material boundary, the lower boundary, upper boundary, and assign a property to the relevant properties to the layer that you create. But if you have a really thin layer of a weaker material, this feature of creating weak layers is very quick, it immediately you can create a weak layer or very thin and assign the properties. And when you run the analysis, because you want to see how the slip surface actually runs along the weak layer, because that's where you're likely to expect the slip surface to go through. It can go through and come out of it. And so try this as well. If you haven't a weak layer, it's with very quickly you can include the weak layer, a thin weak layer, if you try to model that. So this was again a good feature to have. And moving forward, now we are to the present time. So 2020, I know 2020 is known for many reasons, and not just for Slide 2 2020, but for the deadly COVID-19. But while COVID-19 will pass someday, it will go, nothing is permanent. Slide 2 will continue, and this is also not permanent. And realizing that nothing is permanent, that developers of Slide 2 are constantly working on improving this. And in a while, we'll see what the current work is being done on. And so this will continue forever, the developments for your convenience. And so let's understand what is there in the present version. Although rock science now moving away from versioning, and with the introduction of maintenance plus feature, which is constant upgrade. Now you don't have to wait for the next version to come to get your upgrade. When you buy a new software, you get it with the maintenance plus, M plus. That's what the M plus is all about. And whenever a new feature is added, new upgrade comes up, it is automatically sent to you, and you get it upgraded to the next one, rather than waiting for the next version to come. And so the rock science is moving away from versioning, but actually, technically speaking, this is version 9, which you have, but it's called Slide 2 M+. And in this, there's some again some exciting features added, like report generation. I will come to that a little later. And batch printing. You can print various scenarios at one go in batch printing. So I'll try and show you the demonstration also using the actual software. And response surface probability analysis added. Very promising feature, really, and I'll explain in a bit what response surface probability analysis is. And in constant effort of rock science to add real, real materials in terms of support, manufacturer support property tables have been added, and I'll show you that. So what I'm talking about is that, okay, so let me just go back. I will come back to report generation, batch printing a little later. Because I want to, at the same time when I talk with you about this, I'll show you a demonstration. So right now I'll focus on the response surface probability analysis, the third bullet point. So let's go to response surface. Now we have talked about probability analysis. And in probability analysis, when you carry out the probability analysis on certain input parameters, you give a distribution of values, and which can give you a combination of thousands of combinations of possible. Thousands of models will have to be run, 10,000 or more, depending upon what you specify, which can take, based on the complexities of the geometry and the model, can take hours, if not days. So in the constant endeavor to save time for the user, rock science, the Slide 2 developers thought there is a technique called surface probabilistic analysis available. Why not make use of it? And what it does, rather than taking all the thousands of samples, it takes into account, it uses strategically placed samples to create factor safety, a factor safety response surface. I'll show you the example. And so it's, so it samples that response surface, which is based on strategically placed samples for factor safety, instead of computing the factor safety using limit equilibrium method. So, in probabilistic analysis methods such as Latin hypercube, which is extensively used. So the analysis which is done by the probabilistic analysis, which is done by surface probabilistic analysis, is several times faster than the analysis done by Latin hypercube, for example. And the results agree very well with the Latin hypercube sampling. But we always suggest that while you're carrying out the response surface analysis, check it with, for at least some models, using the Latin hypercube sampling to gain the confidence. And let's look at some of the results from surface probabilistic analysis and compare them with Latin hypercube analysis. And so here is an example which has 5 material random variables, 5 material variables. As you know, in the probabilistic analysis, you have these variables and you can assign a range of values to them. So 5 material random variables and 1 water table random variable for this analysis, which was a non-circular surface. And other things are listed here in this table. And as you can see, there's several surfaces were obtained. Let's look at the results. And these are the results and a comparison of the 2 methods of probabilistic analysis. You see the Latin hypercube, 10,000 number of samples, probability of failure is close to 0, and the mean factor safety 1.565, which is pretty close to the mean factor safety obtained by the response surface probabilistic analysis. Very close. The results are very close, and it is based on, instead of 10,000, 168 computations of the strategically placed samples. And but the major difference is the time taken for the running the analysis. While the Latin hypercube probabilistic analysis took more than an hour to run, the response surface probabilistic analysis just took about a minute to run. So this is that kind of difference, and the results when you see here, the density, the overall slope, pretty much in agreement with the Latin hypercube. So, and some more results with Latin hypercube with 10,000 simulations. There were 10,000 computations, but with the response surface probabilistic analysis with 10,000 simulations, there were 168 computations based on strategically placed samples, and the results match. So we would always suggest that to carry out both, at least for some models, and gain confidence in response surface, and then you can continue to use response surface probabilistic analysis. It saves you a lot of time, especially for complex models. And manufacturer support tables, we're talking of the current version, which is M+. And so it's a nice geosynthetics library, now part of Slide2, and you have got the all product line from these manufacturers: Metaphory, Tensor International, Ace Geosynthetics, Husker Synthetics, Tankate, etc. And complete product line is now available in Slide2. And these uses the manufacturer's tested ultimate tensile strength. So when you pick up a particular product from the list, the associated properties get picked up and are used for the analysis. And in addition, the software also uses tables given by the manufacturers, tables of reduction factors. For example, the reduction factors for creep installation damage, the deterioration of service during the service life, and that sort of stuff. And then it computes the tensile strength to be used in Slide2. That was about the Geosynthetics library. And when it comes to soil nails and Grouted Tieback library, the first one to come on board is Dextra, and the Dextra products are now all included, and complete product line is included. And of course, it lists the manufacturer's tested tensile capacity and enters this capacity into the Slide2 analysis when you do that. And the whole idea is that because you are dealing with the real materials as a user, as a in the industry, you are using these products, and so it's so nice and convenient and time-saving to just specify which product you want to incorporate your analysis, and all the properties are included in the analysis, and you can run the analysis with those. So it's a pretty convenient feature, and Rock Science will continue to work towards this. And now is the time to discuss about the printing and reporting. And so I deferred it until now. And so we'll talk about the batch printing and the report generation, which is really a cool feature in Slide2. And I'll try and give you a demonstration also. And so let's first understand this. The batch printing, a lot of customers have been asking about batch printing, that you should have the facility of printing several scenarios, because when you're doing the modeling, you are working with several scenarios and you'd like to print all of them together. So batch printing allows you to do that. Not just that, when you go to the print preview, you often find, and that not applies to Slide2, you often find that you something is not showing correctly and you would like to adjust something, maybe this table is not showing correctly, you'd like to do something. So the annotation tools and other tools which you do in the modeler interpreter to manage things are now available in print preview also. So the moving tools are available in print preview. So using those tools, you can change the things in print preview just before you take the printout, so that the printout comes as you want it to. And the report generator, of course, it's a very cool feature, as I said, instead of the earlier info viewer, which will give you by way of information. This was quite good, but the customers were always asking for more feature rich. For instance, you, instead of info viewer, which is like looks pretty cut and dry, you go to this report generator feature and you've got a nice report in a report format. You've got a cover page with picture which you can change, a logo which again you can change, and you have table of contents which is searchable. You click on anything and takes you there. And not just that, let me see what is there in the next slide. I don't want to say everything now. Okay, batch printing, I've spoken about it already. And this is back. I'll come back to the report a little later. I spoke early. So this is about batch printing. And as I've already told you, and users are looking for an easier way to print lots of views in one go. And as you can see on your screens, that you have this multi-scenarios open here. And when you give the print command, all of them are printed. And I'll show you this through demonstration. You can print all of them or whichever view you want to choose, want to print. Okay, you can choose that. And as I mentioned earlier, the tools are now available in print preview. These tools can be used to resize and move. They can be just as a regular view. And I think I've told you about this. And the report generator, that's what I was talking about. So it's a major overhaul of the info viewer, and it's a standalone application. And users of RS3 and Slide 3 already have this feature. So users of RS3 and Slide 3 will not find this surprising. But if you're not been using RS3 and Slide 3, this is a very pleasing feature which has been added now in Slide 2. And you have a cover page. As I mentioned, you can have your picture there. I mean, your project's picture. You can also have your picture if you want. No doubt about that. And your logo, etc. And as I mentioned some time back, the table of content which is clickable. And I'll show you through demonstration. You can have a document search, and you can insert comments or images. That I'll also show you that. So you can insert comments anywhere you want. You can insert images, and then one exciting feature is report views. So you can go to the interpreter. You can choose a view and just send it to the report. It will be included in the report, and if you make any changes in that view, it gets changed in the report also when you run the report again. And page breaks are there. You can export it to PDF. There are nice header and footer options in this. Of course, and you can customize the fonts, margins, watermark, etc. to your liking in that. And so what is coming soon? Before I go to what is coming soon, allow me some time, because I want to go to a quick demonstration, because I'm conscious of the time also. So just allow me time. And I hope you can see this slide interpret in which this is based on tutorial 6 of Slide 2. And what I'm going to show you quickly is that you can, when you take print, and this is what you see. If you select all the scenarios which are open, all of them will be shown in print. And you can see that if I scroll, I mean, if I take you through views, this is one view that you see, and master scenario. That's what they see. You can go the footer here. And if I go to the next view, this is no support scenario. The next one is with Tieback support. So you can print all of them, and they show up at page 1, page 2, page 3. So that's batch printing, which is added to Slide 2. So again, a good feature in this. And then, so let me close this and go to the report feature. We are really short on time. So this is here, the report generator is. Sometimes takes time, depending on. Okay, it's getting into that mode. You can see the generating report, and so you will soon see a report has been generated, and it's coming now. Yes, it is there. I hope you can see it's coming. Yes, now you can see that. You can see the cover page. Let me make the size a little small so that you see entire thing. So the logo, the cover page, everything is there, and all this is included. The right panel, whatever is checked is included in this. You can choose to remove some of these things or include all of these things. It's your choice, whatever way that you want your report to look. And if I take you through this, go down, table of contents, and that's how it goes. And you know, if you go to, for instance, this table of contents, you can click anywhere, and it'll take you there to that part. And also, you can have the document map here on the left side. You can see in terms of pages also. Pages can be seen, and you can search anything. For example, anything that you type, you can search for it, and there it is. It takes you to that search result in the report. Now, if I go back to the interpreter, and I will show you the report view, which I mentioned in the presentation. So if you want to include this view, for example, in the report, what view, add view to report. So it shows the name, etc., which you can change actually. I say, okay, it goes to the report. We'll see. Let's take another view, maybe a closer view of this scenario, any other scenario, maybe this. And again, we go to view and add view to report. Okay, so I'll have to generate the report once again to update the report with these views. And these views will show up in the report. And you know, if you come back and make some changes here, those changes will reflect when you regenerate the report once again. And that's, the report is coming on. Yes, there it is. So if you look at the last one, report views has been added. If I click here, that's what you see. The reports views added, this one and the next one. Here, remember that closer view, and with the title and everything, which you can change, you can manage all of that. You can give nice titles. So this way, this facilities was there. So I will now go back to the presentation after this quick demonstration. Okay, I hope you can see the screen once again. So what is coming soon in slide 2? And what is coming soon now, what we are working on, what the developers Slide 2 are working on, are these things: multi-modal optimization, which is which I'll explain, try to explain. And since these things are still not out, so let's understand what multimodal is. And then probabilistic analysis using coefficient of variation, rather than working on variation of parameters, variation of, for example, shear strength, coefficient of variation. We'll discuss a little bit more. And then improving optimization to account for anisotropic. In fact, a lot of effort is now being spent on anisotropy, because anisotropy can be a major issue with certain ground conditions. So multimodal optimization, and you know, when you talk about factor safety map, it gives you a good indication of low factor safety regions, but doesn't give you the lowest factor safety in that sense. And so while you can get the lowest factor and the global minimum, the lowest factor of safety, but you see in a model or in a slope, you could have different modes of failure. For example, you can have a deep failure, you can have a shallow failure, you can have a failure which is going beneath the support, you can have a failure which is going through the support. So often as engineers, you do not only want the minimum factor of safety, but you want to know the factor of safety for these modes, different possible failure modes, such as like these two graphics that you see on the screens. Each has 3 modes of failure shown here: shallow, intermediate, and deep. Some of them could be going through the support, some of them could be going beneath the support. So you would like to know that what are the factor of safety for these different modes, rather than looking at one factor of safety for the entire slope. That's what is the multimodal optimization is. So, which is what would be included in the features in the near future. And then second is coefficient of variation. Now, coefficient of variation, basically, it's the random, in this case, the random variable, for example, is the shear strength and not the parameters. You can do the variation or distribution of property values for example, for cohesion. You can have a variation, distribution of cohesion values. You can have distribution of friction angles, for example. But now you can do with shear strength rather than working with parameters, work with the shear strength. And it's applicable to all strength models. And so on your screen, and this is what the new feature would be. And you will see on your screen what you see is an isotropic function. For an isotropic case, this application of coefficient of variation being shown. So this is something, the major difference is rather than working with the distribution of individual parameters, you're looking at the distribution of the value which is based on those parameters, such as shear strength. And another feature is this anisotropic materials and optimization. As I said, a lot of work is, there's a lot of conscious effort to unravel the understanding the anisotropy. And it's more pronounced in areas where you have rock engineering situations. And so currently it is for weak kind of situations. It's currently if you have a narrow, for example, if you have a narrow angular range of low shear strength in an anisotropic model, with the current capability, it's difficult to do the optimization to fit in that narrow range. Especially when you have multiple materials. So the work is in progress in sort of improving that situation. And so more of that will be available in course of time. But if you're really interested to know about it, the right people to answer these questions are the developers. And so if you have any questions about these developments, please send those questions, and developer of the software would be the best people, but they know what exactly is being done to answer those questions. And so this is just about what I wanted to share with you. And the next webinar in this series is going to be on 17th June, same time, and that would be on seepage and stability analysis, followed by the third webinar 2 weeks after the second webinar. And in addition, I also wanted to share with all of you that the Rock Science through the India office is going to soon announce an online course on use of various software tools from Rock Science for design and analysis of underground openings, such as tunnels and caverns and underground excavations. And so those are the areas many customers have asked us for that. And so we'll be coming up soon with the announcement for an online course which will run for several days, maybe 2 hours every day. And so we'll keep you informed about it. If you are interested, you can send us an email about this. We'll soon announce this. It will include all the software tools from Rock Science which are used for design analysis for underground openings, such as rock support, which is based on convergence confinement method, such as RS2, which is a finite element based, such as RS3, which is a 3D finite element based program, such as Unwedge, which looks at the completely different aspect of instability in underground openings, which means structurally controlled instability, in which you will analyze the chances of wedges and blocks falling or sliding into the tunnel. So all of that would be included there, and we'll talk about the subject and application of these software tools for proper analysis and design of tunnels and underground openings. So that's about all from my side, and let me check. We don't have much time to answer questions, but let me see if we can take some questions. I can't see any questions here. Oh no, there is one. Yeah, there is. Yeah, sorry. Okay, the question is, what are the special additional features that Slide2 have to convince loyal slope W users, especially the authorities, or government agencies, all these while they are only familiar with slope W. Well, this is maybe true in the customers or clients that you may be dealing with. It's not true everywhere, but the only thing that we can do, we can be honest about our features, our capabilities, and we are always open and very friendly in telling you about the features. We are prepared to do a session with the authorities that you're talking about. If there are webinars like this, we can have one-to-one sessions with them, and we can get our best of people who are from rock science to tell them about the features of Slide2, and that's so we can do all of that, if to convince them. And in fact, webinars like these are actually a part of the effort in letting the world know about the Slide2. But it's a very exciting place, rock science. If you visit Toronto in Canada and make a visit to rock science, you will feel the vibe. Of course, after COVID-19 leaves the world, then you can go and meet. It's a very vibrant place and buzzing with expectations and lots of new developments taking place. And so all of that will rub off, I'm sure, when we have a session with your clients. So that's about it. And so I think we can, I can't see many questions here. So just a minute. And so since the time is also up, I don't want to take much of your time. So what I suggest, your questions, please keep sending your questions. They will be with us, and we'll send an email to all the participants with the answers to all the questions asked. And so with that, it's time to say bye-bye to all of you till we meet again on 17th June. And so thank you very much, and see you soon.